Hi everyone, welcome to Math with Mr. G. Today we'll be discussing factoring expressions. Okay, this is the fourth section in chapter 3, the final section in chapter 3. Today when we're factoring expressions, what we are essentially doing, I like to think of factoring expressions as the reverse of distributing. So last section we learned how to distribute, which was kind of like taking a number and multiplying it by an expression. And this section you're going to be given an expression. So for example, 24x minus 18. And you're going to try to factor that by essentially reversing the distribution. And that might sound a little confusing, but we'll go through a few examples and I think you'll catch on. And for our vocab today, we have when factoring an expression, you write the expression as a product of factors. So product, again, in math means to multiply. Just a good reminder there. And it says you can use the distributive property to factor any rational number from an expression. So we'll try that here in just a second. I forgot about the learning target. Let's quickly add that in. I can explain how to factor expressions. All right, so let's try that. Let's try to factor this expression. It says factor 24x minus 18 using the GCF. Remember, the GCF stands for the greatest common factor. Okay, so to find those, one way we found the greatest common factor is we use the list method. Factors of 18 and 24. Remember, factors are numbers that multiply to get to this number. So for example, 1 times 18, 2 times 9, 3 times 6. And those are all the factors. The factors of 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Okay, and there are two lists of factors. Now we're looking for the factor that is the greatest common. So the highest number, the greatest number that they have in common. So let's look at our list here. It looks like 6 is the factor that is the greatest that they have in common. Okay. Once I have found the factor, that is essentially what I'm going to be factoring out of this expression. Okay, so I'm going to take 6 out of 24x minus 18. So what I do is I write down that factor, and then I add in parentheses. Okay, if I were to divide out 6 out of 24x, that's like saying what is 24x divided by 6? I'm factoring 6 out. Well, 24 divided by 6 is 4. And then just bring this x along for the ride. I'm subtracting minus what's 18 divided by 6. Again, I'm factoring 6 out. Well, that should give you 3. Okay, so you should arrive at 6 times 4x minus 3. That would be your answer. And now you might be able to a little bit more clearly see that factoring is kind of like the reverse of distributing. Because if we were to go ahead and distribute 6 to this, we would come up with 6 times 24. 6 times 4x is 24x minus 6 times 3 is 18. Okay, but again, that's just kind of how I want to show you that it's kind of like the reverse. Okay, but this is the final answer. We factored out the greatest common factor. Okay. So why don't you pause the video now and try to do the same for 1, 2, and 3. Figure out the greatest common factor and then factor that out of the expression. All right, hopefully you got a chance to do these three. Let's see how they went for you. Greatest common factor between 15 and 25, I believe, is 5. So again, I'm going to write down my greatest common factor, then write my parentheses, and then ask myself, what is 15x divided by 5? 15 divided by 5 is 3x plus 25 divided by 5 would be 5. And let's just double check that if I were to distribute. 5 times 3x, 15x, plus 5 times 5, 25. Yep, that's right. Okay, factoring out the greatest common factor from here. 4 would be my greatest common factor, GCF. 4y divided by 4, well, 4 divided by 4 is just 1y, minus 20 divided by 4 is 5. And then lastly, greatest common factor between 36 and 24. Let's see, that should be 6. So I'm dividing both of these terms by 6. Again, I put 6 and then my parentheses. 36c divided by 6 would give me 6c, plus 24d divided by 6 would give me 4d. Okay. If you have questions on any of those, please let me know and I can help, or phone a friend. Let's move on to example 2 now, where we're doing the same, except now we're using fractions. Okay. It says factor a half out of 1/2 x plus 3/2. Okay, so we're doing the same. Now we just have fractions. So we just have to remember how to divide fractions. In fact, it wants me to factor out a half, so that's what I'll put on the outside. And then what's a half x divided by a half? Well, anything divided by itself is 1, so 1x, plus I'm adding 3/2 divided by a half. Okay, 3/2 divided by a half. Remember this acronym for dividing fractions: keep, flip, keep my first fraction the same, flip division to multiplication, and flop to its reciprocal, right? Make the numerator the denominator and the denominator the numerator. Now I can multiply across. That would give me 6 over 2, which simplifies to 3. Okay? So there I just factored out a half. Let's check that. If I were to redistribute that half, 1/2 times x is 1/2 x, and 1/2 times 3, 1/2 times 3 over 1, 3 over 2, just exactly what we started with. Okay, so again, when I factor out a half, I divide by a half for each of these terms. Why don't you go ahead and try 4, 5, and 6 with these other fraction problems. Go ahead and pause the video now. Alrighty, factor out the coefficient of the variable term. So remember, the variable is the letter. The coefficient is the number in front of the letter. So here I'm going to factor out a half again, because that's the number in front of the letter. So a half divided by a half is just 1n. I'm subtracting, and half divided by a half is 1. Okay. Number 5, this time I'm factoring out 3/4 because that's the number in front of my variable. So 3/4 divided by 3/4 is 1p, or just p, minus, then I can take then I need to take 3/2 and divide it by 3/4. So it's going to help me to write that out. 3/2 divided by 3/4. And again, I'm going to keep flip-flop. So 3/2 times 4/3. That would give me 12/6, which would simplify to 2. So 3/4 times p minus 2. And then lastly, I need to factor out 2.5 because that's the coefficient to my variable. So 2.5 is what I need to factor out. What is 5 divided by 2.5? Well, 2.5 goes into 5 twice. Plus 2.5 divided by 2.5 is 1. So 1 cubed. Here's my final answer. All right. That does it for those. Again, let me know if you have questions, and we'll move on here to our last set of problems, where now we're factoring out a negative number. Okay, it says factor -2 out of -4p plus 10. So, in other words, I'm factoring out -2, so put that on the outside of my parentheses. What's -4 divided by -2? Well, again, same sign, that would give me a positive 2p plus, I'm adding, 10 divided by -2. Well, now I have a different sign, so it's going to be a negative, and 10 divided by 2 is 5. I'm going to add in another set of parentheses, so that looks a little bit neater, so I know I'm adding a negative number. Okay, so lastly, pause to try the same for 7 and 8. Alrighty, for 7, I have factor -5 out of -5d plus 30. So factoring out -5, I'll put that on the outside of my parentheses. What's -5d divided by -5? Well, that would be same sign, so positive 1d, plus what is 30 divided by -5? That would give me -6. Okay. And then factoring out -4 out of this expression, -8k divided by -4 will be 2k. And then I have, I'm going to change this to addition, and the next to its opposite, little chop method there, plus -12 divided by -4 would give me +3. I always like to do that chop there, so I'm working with addition and then its opposite. Okay, so that wraps up factoring. Hopefully by going through those examples, that really helped you figure this out. Again, I like to think of it as the reverse of the distribution method. So please let me know if you have more questions, and I'll be happy to help. I will see you guys later.